Bismillahirrahmanirrahim. Assalamu alaikum students. I hope all of you will be fine. Students, today we are going to start unit number 11, that is sound. In this unit we will discuss what is sound, how sound is produced, what is the nature of sound waves, and what are the characteristics of sound wave, and furthermore, students, you have learned in the last chapter, that is chapter number 10, simple harmonic motion and waves, that the sound is an example of mechanical waves that needs a medium for their propagation. So, in this lecture, we will discuss the topic 10.11, and the topic is introduction, definition and explanation of sound waves. In this topic, we will learn what is sound waves and how sound is produced by a vibrating body with the help of an activity, and sound requires material medium for its propagation with the help of an experiment, and we will also discuss that the nature of sound wave is longitudinal. So we will discuss it one by one. First of all, what are sound waves? Sound wave is created by a vibrating object such as the string on a violin, your vocal cords, or the diaphragm of a loudspeaker, like this. This is a tuning fork that shows how sound waves is produced. When it vibrates, the sound waves is produced. Sound waves can be transmitted through gases, liquids and solids. If there is no medium, there is no sound. You have discussed it earlier that sound wave do not travel in vacuum because they need some medium, because their nature is mechanical. How sound is transmitted? A sound is created by the cyclical collision of atoms and molecules such that it is transmitted through the bulk matter. Look at this, student. The sound is transmitted through the bulk matter due to the cyclical collision of atoms and molecules. You know, students, that the doctor use stethoscope to check the heartbeat of human beings, and how it is possible, how a stethoscope is used to do this. You can clearly understand with the help of this video.
Stethoscope. A stethoscope is a medical instrument used to listen to sounds produced in the body. It is most often used to listen to hear sounds and breathing. It is also used to listen to intestines and blood flow in arteries and veins. The stethoscope was invented in France in 1816 by physician René Laennec. There are two types of commonly used stethoscopes, electronic and acoustic. Acoustic stethoscopes consist of a chest piece, two hollow air-filled tubes and the earpieces. There are normally two sides to the chest piece, the diaphragm, a plastic disc, and the bell, a hollow cup. When the diaphragm is placed against the patient, the sounds of the body vibrate the plastic disc and acoustic pressure waves are formed. These pressure waves travel up the hollow tubes to the listener's ears. The diaphragm side of the chest piece is useful for transmitting high-frequency sounds. If the bell is placed against the patient, the vibrations of the skin directly produce acoustic pressure waves that travel up the hollow tubes to the listener's ears. The bell side of the chest piece is used to transmit low-frequency sounds.
I hope, students, this video helps you to understand the working of stethoscope. Now, we will discuss sound is produced by a vibrating body. How a sound is produced by a vibrating body? The activity 11.1 is given in your textbook. Please, student, read it properly and you can understand it by watching the video.
Let's perform an experiment, which will allow us to see the sound vibrations as they travel through a medium. For this experiment, we'll need a tuning fork, a rubber mallet, and a wide container of water. First, we'll place our container of water on the table, giving it time to become completely still. Use the rubber mallet to strike the tuning fork, and then insert it about 2 inches into the water. As you do this, you can watch the vibrations of the fork create ripples that are moving through the water away from the fork. Now let's look more closely at what actually was happening when the vibrating fork was immersed. When the tuning fork struck the surface, water molecules bounced off the fork because of its vibrations. The vibrations of the molecules nearest the fork then vibrated the neighboring molecules, which in turn vibrated the molecules next to them. In this way, the vibrations, or waves, move through the water in the form of ripples until they reach the other end of the container. In a vacuum, there will be no molecules or particles for sound vibrations to move through. That means that sound cannot travel through a vacuum.
I hope students this video help you to understand that how sound is produced by vibration. Now remember one more thing, that sound cannot travel through a vacuum. As we discussed in the last unit that the nature of sound wave is mechanical. So the mechanical waves must have a medium through which they move. This medium can be solid, can be liquid, or can be gaseous. And to show that the sound wave is mechanical in nature, that the sound wave need medium for its propagation, let's perform an activity that is given in your textbook. The activity 11.2 is on page number 21.
Take an electrical bell and an airtight bell jar. The bell is suspended inside the airtight bell jar. First, press the switch for the bell and you will be able to hear the bell clearly. The bell jar is connected to a vacuum pump as shown. Now, start to pump the air out of the jar gradually. You will hear the sound becoming fainter, although the same current is passing to the electric bell. Soon you will notice the less air is left inside the bell jar, the less the sound becomes. If the air is removed completely, you won't be able to hear any sound. From this experiment, we can understand that sound cannot travel through vacuum.
Okay students, from this activity the conclusion is that the sound wave can travel only in the presence of medium, and in this activity the medium is air. Students, now we discuss the longitudinal nature of sound wave. Sound wave की nature longitudinal है कैसे? हम ये डिस्कस करेंगे। इस फिगर को देखें, हमारे पास एक ट्यूनिंग फॉर्क है जिसकी ये मेन पोजीशन O है, ये प्रॉन्ग A और ये प्रॉन्ग B है। अभी जब तक हमने इसको वाइब्रेट नहीं किया तो क्या होगा? इसके राइट साइड पे ये जो प्रॉन्ग B है, इस साइड पे जो एयर है वो यूनिफॉर्म है, उसकी डेंसिटी में कोई वेरिएशन नहीं आ रही। क्यों? क्योंकि ये वाइब्रेट नहीं कर रहा अभी। तब तक वो एयर की डेंसिटी क्या है? यूनिफॉर्म है। लेकिन जैसे ही उसका राइट प्रॉन्ग मूव करेगा फ्रॉम द मेन पोजीशन O टू द पोजीशन B, तो क्या होगा? इट एक्सर्ट प्रेशर ऑन द एडजेसेंट लेयर ऑफ एयर मॉलिक्यूल। ये जो एयर के मॉलिक्यूल की एडजेसेंट लेयर है, एक के बाद एक लेयर पे जब वो प्रेशर एक्सर्ट करेगा तो क्या होगा? वहां पे हमारे पास एक कंप्रेशन प्रोड्यूस हो जाएगी, मतलब एयर के पार्टिकल कंप्रेस हो गए हैं। ये कंप्रेशन प्रोड्यूस होगी और ये तब तक होती रहेगी जब तक ये एयर के जो पार्टिकल है वो एडजेसेंट लेयर पे मूव करेंगे। लेकिन फिर क्या होगा? A moment later, the prongs began to move from B toward A. फिर क्या होगा कि वो अगेन B से ए की तरफ जब मूव करेगा तो क्या होगा, अब जो एडजेसेंट लेयर पे प्रेशर है वो भी क्या हो गया, डिक्रीज हो गया। और जब प्रेशर डिक्रीज हो गया है इसका मतलब है कि अब डेंसिटी इस जगह पे क्या है, ज्यादा है, मतलब पार्टिकल के दरमियान जो डिस्टेंस है वो भी क्या है, एज कम्पेयर टू कंप्रेशन वो ज्यादा है। सो अ रेयरफेक्शन इज प्रोड्यूस्ड हेयर, तो एक रेयरफेक्शन प्रोड्यूस्ड हो जाएगी और ये रेयरफेक्शन ट्रांसफर करेगी एयर लेयर को नेक्स्ट टू इट एंड सो ऑन। इसी तरह ये ट्यूनिंग फॉर्क जब बैक एंड फोर्थ मूव करेगी तो हमारे पास एक सीरीज ऑफ कंप्रेशन एंड रेयरफेक्शन प्रोड्यूस हो जाएगा। एंड इन दिस वे द साउंड वेव प्रोपगेट थ्रू द एयर, और इसी तरह एयर में साउंड वेव प्रोपगेट हो जाएगी। And this shows that the sound wave has longitudinal nature. As we discussed before, that the distance between two consecutive compression or rarefaction is called the wavelength of wave. In this figure, that is this wave is shown the longitudinal wave that is formed by the vibrating tuning fork in the air. Compression are the places where air pressure is slightly higher than the surrounding air pressure due to high density of air particle, while the rarefaction or the region correspond to the low air pressure due to low density of air particle. अब हमें यहाँ पे इस फिगर में आप ये क्वेश्चन भी आपको आ सकता है कि व्हाट इज द डिफरेंस बिटवीन कंप्रेशन एंड द रेयरफेक्शन। तो आप इसमें 2-3 पॉइंट लिख सकते हैं कि कंप्रेशन में जब हमारे पास कंप्रेशन प्रोड्यूस होता है या कंप्रेशन वाला जो रीजन होता है वहाँ पे एयर प्रेशर भी हाई होता है। क्यों? क्योंकि वहाँ पे डेंसिटी क्या हो जाती है, हाई हो जाती है, पार्टिकल्स वहाँ पे ज्यादा क्लोज आ जाते हैं। लेकिन रेयरफेक्शन में क्या होता है कि एयर प्रेशर भी लो होता है क्योंकि एयर की डेंसिटी वहाँ पे लो हो जाती है। इस एग्जाम्पल के अलावा एक और एग्जाम्पल है जो ये शो करेगी कि साउंड वेव के नेचर क्या है, लॉन्गिट्यूडनल है, और वो आपको इस वीडियो को देख के बहुत क्लियरली समझ आ जाएगा कि कैसे साउंड वेव की जो नेचर है वो लॉन्गिट्यूडनल है। सो स्टूडेंट्स, वॉच दिस वीडियो।
How is hearing possible when a drum is beaten? When a drum is beaten, the air around the drum experiences high pressure. The air, which are very close to the drum, are pushed away from the drum. This displaced air exerts a force on the adjacent particles and come back to its mean position. This process continues in the medium till the disturbance created by the vibrating object reaches our ear. Thus, sound propagates through air in the region of high pressure and low pressure. The region of high pressure is experienced in places where the particles of the medium are very close to each other, is known as compressions. It is denoted by C. The region of low pressure is experienced in places where the particles of medium are far apart from each other, is known as rarefactions. It is denoted by R. Here the particles are vibrating along the direction of propagation of the disturbances. This wave is known as longitudinal wave. Longitudinal wave is a wave in which the particles of the medium vibrate in a direction parallel to the direction of propagation of the wave. This creates compressions and rarefactions alternatively in the medium. Wavelength is the distance between two consecutive compressions or rarefactions.
आई होप स्टूडेंट्स यू गॉट इट। इन दोनों एग्जाम्पल्स में हमें यही पता चला है कि क्या है, साउंड वेव की नेचर लॉन्गिट्यूडनल है। पहले हमने ट्यूनिंग फॉर्क के थ्रू डिस्कस किया एंड इस एग्जाम्पल में ड्रम के थ्रू ये चीज डिस्कस हुई कि जब हम ड्रम को बीट करेंगे तो साउंड वेव किस फॉर्म में ट्रेवल करेगी, लॉन्गिट्यूडनल फॉर्म में ट्रेवल करेगी। आई होप स्टूडेंट दिस लेक्चर हेल्प यू टू अंडरस्टैंड द कॉन्सेप्ट ऑफ साउंड वेव्स in detail. And at last, it is the time for your home task, which includes the first 6 review questions from exercise. Students learn all these questions properly along with the topic. And in the case of any question, you can ask me is